Yep, it says you started recording. All right, got it.
I'll just wait a few minutes. We're a little early, but I'm going to go into a lot of the parts. As you can see, the stuff I have on the desk.
Yes.
Okay, I also have like a screen presentation, and we're going to go through all these. So we're going to cover some stuff that air conditioners use, like a fan relay or a contactor, because they're all relays. So if you can understand one, you can understand them all.
Right.
So I don't want to get started too much because then other people come in and they're going to miss everything.
Got it.
All right, now I have to go. Where's screen share? So now you guys should be able to see some of these things I have on the screen.
See it.
Okay.
Flash flow.
Yeah, I got different types of switches, thermostats, like how they work, what they do, information you need to know. Okay, so that's that. Switches, there's a fan relay. Get into relays after switches, so I'll go here, start with this. All right. And then we'll go back to stop presenting. And then we're back to screen. Now, when you guys see this screen, all you're seeing is my screen, right? Or are you seeing like everybody's windows? I guess you have the option to choose what you see, right?
But we have the option to turn video on or off. But yeah, I only see your screen.
Yeah,
Well,
I'm not
I mean,
talking about your video, but like you could see just
the
this.
desktop, the desk. I only see the desk with a keyboard.
All right, cool. I just want to make sure because I had a lot of problems with this computer today, and I even had to reboot my internet, restart the computer twice. The software crashed. I'm like, oh god, I'm not gonna get this going by 12.
Got it.
I've been working on it for an hour now this morning, setting everything up.
You know how it works, right? It works fine until you get ready to go live.
Listen, you don't know how I don't know if you guys saw the sealed system lectures, restrictions videos that I've been putting up on the YouTube channel. And there was another 30-minute part of the video where I was on the board and I'm explaining a little more about the condenser and how we're setting up the condenser. And then I go to the video and the video has no audio at all. And it's like, oh my goodness. So now I have to figure out what do I do with that video.
Yeah, I was thinking you lay that video on the track and talk over it. You know what I mean?
Yeah.
Yeah, I'll just lay audio on top of it.
Yeah, but the hard part about doing audio over top of it is like, the camera, I don't see my mouth moving and I don't remember everything that I said in the lecture. So let me see something here.
Okay.
This is the video. I'll share my screen in a second here. Here, screen share. So this is the video, and I'm upset because if you see, I got my microphone on, and I didn't realize that no one told me it's blinking, so it lost communication. But if you look, I had a video. Let me see, guys.
Testing 1, 2, 3, 1, 2, 3.
Wait, let's see here. Show your entire screen. So here's where I did a test. on the video the other day?
1, 2, 3.
My microphone's working.
1, 2, 3. 1, 2, 3. Testing.
So then I got the second video here, which is the actual video, and not one bit of audio. Somehow I lost the connection to the audio in the whole lecture. So I might have to redo that one, but this is all part of that sealed system one that I put up on the YouTube channel. Anyways, welcome everyone. I'm just going to wait about 2 more minutes and then we'll get started. Let me bring up this screen here. And for those of you who just come in, I have an assortment of parts here. We're going to do both a little bit of actual demonstration with the parts and show you some things on the parts, but we're also going to use the computer. So we're going to go back and forth between the hands-on part as well as the lecture. I'm just going to sort of start off talking. Anybody else comes in, they can catch it. I am recording this just in case anybody knows. Feel free to ask any questions at any time, and I'll stop at time and see if you guys got any questions as well. The one thing about troubleshooting and fixing appliances, and I was talking to one of my students in class the other day, is like, listen, you have to understand the basics of how everything operates. So then when something in your machine is not working, you know, oh, I know that if the lock mechanism on the top load washer is not locking properly, the washer's not going to work. I've had people go there and change control boards, change motors and drain pumps, and later they're ordering the lock mechanism. And I guess part of it is not knowing how to test it and how it works. So it's real important that you know all these parts one at a time. And a lot of people say, well, how do I study appliances? You know, I'm at home and I don't have a school I can go to or anything like that. How do you actually study this stuff? And really, you're just going to have to get one machine at a time and take one part off the machine at a time, every part, just like I got all these parts out here. And you have to know how they work. I could look at all these and tell you so much detail in just about this one little part, how it works, how to test it, what's actually going on inside when you look at it. And the more you understand this stuff, the easier it's going to be when you're actually out there trying to troubleshoot and fix the appliance. So let's just talk about, I'm going to share my screen for a second here. Just real simple. What is a switch? What is a switch? Anybody know?
It turns the component on and off. Okay,
so that's what it does, but it is a control. In other words, you know, if you want a washing machine to work, what key things does a washing machine do? A washing machine will fill with water. The motor will run and it'll wash. There's maybe a separate pump, like a drain pump, to drain the water out. You have all these different things that the machine's going to do. I'm sorry, 1 second. For some reason, one of my students just said the link's not working. So I had an issue in the email too. I had to copy and paste it for some reason. When I clicked on it, it was taking me to the wrong thing. So a switch is what we put in a machine to turn on all these parts, motors, water valves, drain pumps. We have to put a switch in front of every single one of them for 2 reasons. One, if we don't have a switch on them, let's just say I got a motor, okay? Well, if this is a drain pump or motor or whatever, if I hook it up to power, it's going to run all the time, right? So a switch has got to be a way to turn it on and off. And in a lot of machines, one switch is not enough. And I'll talk about that in a little bit once I go over like the basics of this stuff. One switch is not enough because, for example, the old style direct drive washer. First thing the machine does, as the water comes in the machine. But the motor's not running right now. Well, if you actually were able to read the wiring diagram, you could see that the wiring diagram will show the timer switches that are sending power to the water valve are also closed and aiming at the motor right now too, but the motor's not running because it's waiting for a water level switch, which the point I'm trying to get is we have a switch and a timer. And let me just go back to this to this here, if you can see the screen. This is a timer for a dryer. Okay. And there's a bunch of switches in here. I'm going to actually open this up in a little bit and show you inside. There are switches that are all connected to all these pins here. So they could be closed inside of here. It doesn't mean that it's sending power to the motor or sending power to the heating element at that moment. It may be requiring other parts as well. Like right here, this is a type of thermostat. Okay. And if I want the heating element to come on, the timer's going to turn it on, but the timer is not going to control the temperature of the heating element. So we have to, and I got some stuff here to show you. In the timer, we have to bring power into the timer. So we connect a wire with power coming in, for example, and it goes in here to a switch, and it's going to come out the timer. Let's just say here, to turn the heater on. Now that's all good, because what does the timer do? The timer runs and it's set for a specific time, 20 minutes, 30 minutes, or whatever. And then the timer times out, that switch opens, the heater cuts off. But if I don't have a way to control the heating element, I'm going to burn the clothes or damage stuff in the machine. So instead of this going directly to the heater, I'm going to hook this up to the thermostat. Now, off of this thermostat, I'm going to go to another thermostat or to another part before I get to the heater. And each one of these parts has a specific reason for why they put it there and what it does in its installation. So let's go back to sharing my screen. So in here, we put a switch and okay. In here, we put a switch, and this switch turns this motor on and off. Okay. And we have many different types of switches. We have mechanical switches like door switches, door lock switches. We have thermostats. We have switches that are cycling on temperature. We have water level switches. We have relays. We have bimetal switches, which are like thermostats. And I'm going to show you a little bit how they work. So let's go to well, actually, I didn't want to go to that. I had a microwave door switch, but give me a second. I had to reboot the computer sometimes. Okay, so if you look here on this screen, these are microwave door switches. Simple switch. I got videos on it. I'm not going to go into a lot of detail on that switch. But look at what they have here. If you look, is that a normally open or a normally closed switch? I'm going to go into a little bit more basic in a minute, but I just want you to look at it and tell me what you think.
Normally closed.
Okay, you sure it's normally closed? Look at the pin location, and I can't keep it open. There we go. This one has a normally closed here, and the drawing is showing common to normally closed, but there's no place to connect a wire up here. Okay, if you look at the bottom one, it says NO, and you have a place to open up, or not open up, but to connect a wire. So you can only connect a wire on the bottom here where it says common, or you can connect the wire here. And normally closed, when you hear these words, and I tell you, it even confused me when you first talked about them, is that is when the switch looks just like this, like there's nothing pressing down on the little red button here. So right now, this switch is normally open, and when I close the door, then this switch will go from common to NC to common to NO. And I have a switch here open so I can show you guys inside. Now this one here is a normally closed switch. Why? Because they moved the pin location where you can connect the wire to the top instead of the bottom. And then they have the switches that may have one here, and here, like 3 places to connect. That's normally open and normally closed. We call that a single pole double throw switch. So let's go back to the camera. And if you look here, I have a micro switch, and I'll bring it up closer to the camera for you to see it. This micro switch has a place to connect 2 wires. One on the bottom. I don't know if you guys can see it. Is it in focus there? It's a little hard to hold focus with the camera here. But there's one on the bottom here. And this one here is going to which pin? Is it going to the normally closed or the normally open? See if I get closer. Just the camera's not focusing too well. It's the normally open position. So that means right now, if I test this with a meter, and I have a meter here. My trusty analog meter here. I don't know if you guys can see it. The light here coming in is reflecting off my screen here. There we go. Sorry. I'm going to turn it this way. So if I check the 2 pins of my switch, right now, when I touch the meter leads together, the needle moves. I don't know if I was on ohms, it would help. Sorry, guys. So right here, when I touch the meter leads together, my meter lead moves. And then when I open it up, it goes like that. That's what's happening on a switch. When I touch a pin of a switch here and touch the other pin of a switch here, there's no reading. But when I press it down, watch the needle, reads. Now this meter is actually giving me 2 different tests at the same time. Does anybody know what those 2 tests are that I just made? And not because I did it twice, but when I did it, I actually had 2 different tests. Anybody know? Okay, well, one test was that the needle went over and actually gave me a resistance value. I didn't adjust the meter, but it actually went over, and the needle moving was measuring resistance. Now, we want to do that when we check, like, if I want to check this timer motor, I'm going to check the motor for resistance. If I'm going to check this relay or contactor, what we call coil, which is this side and this side, where when we give it power, the bottom part of this is a magnet, it pulls this switch down. That's got to have some resistance. And that's what the needle moving said, but it also gave me an audible tone. And that's called a continuity tester. So some people get continuity and ohms confused. Continuity just means from one side of the part, and I got this switch open to show you, from one side of the part coming in and out, it has a continuous path. And on a switch, I'm more concerned about continuity than anything else. I can ohms test it if I want. And my meter said I had a certain amount of resistance in there, but that's because if you look at this switch, look at the discoloration that happened here where the wires connect. Because what happened is, unfortunately, in these microwaves, they make these switches where they're underrated, and the contact, the little point in here. Now watch, I'm going to press it down because this here is normally open. When I press it down, it closes. You see right there above my finger, right there where the contact of the switch is closing. Now electricity comes in, this whole piece of metal here, oops, I knocked the pin out. That whole piece of metal is live with voltage and active. Let me put this pin back in. So current doesn't just run, but All it is a metal connection connecting. Put that back together. A metal connection allowing power to come in and power going out. That normally open because right now that is open. Now, if you look, the pin locations on the two are identical. So that's what's going on inside. And you can open these switches up. And here you can see the inside of this one, the same thing. When I press it down, it makes contact. When I let go, it lifts up. Now,
So
some
Ricky,
of the, yes, sir.
sorry. That's one of those single throw switches, right? I can barely see it, but it
Yeah.
looks like one. Okay.
It's a single pole, single throw.
Single throw. Okay.
So can you see that now?
I'm trying to see my computers. Your screen is so small.
Is it?
Well, I see everybody else larger than your screen on my end.
I think you can double click on my image or something and make my image full screen where you don't see everybody in the
Okay.
chat. Try to double click on mine, or there might be a button that will make it like full screen, like it's the center of the screen.
Yeah, I'm trying now. It's not working.
I'll give you a second. Did anybody else know how to do that? Pin yourself to your main screen. Does that do anything?
Mm-mm.
Or how about, can I share a screen of my own screen? Let me see.
Nope. Okay,
No,
it's bigger. It's bigger now. Well, no, it went back
no,
even
never mind.
smaller.
No, I just said, how about now?
No, it's the same the way it was before. Because before it was perfect, and then it switched to show everybody's screens.
Okay, I don't know how to do that as far as that goes, but
Okay.
if you guys can see, you can see that image is a lot clearer now. I don't know how to make myself the focal point here. Let me see something. One last setting. Don't have the figure out a way to do that. I think if you double click it though, it should make it bigger. Because if I did double click on any of you, it makes everybody else small. Okay, so anyways, that's just a simple switch. Let me go to my screen presentation again here. And if we look, this is inside a dryer. And I had a typo here, push to start relay. Sorry. This is a push to start relay. Now, not all dryers use push to start relays. And if you see on the screen, I have that exact device here. What is a relay itself? Not just a push to start relay, but what is a relay?
It's like a switch, but it doesn't it open and close a circuit or something like that?
Yeah, it is a switch. And if you look here, I drew a switch on the screen.
Mm.
But what they add, if you look right here, can you see the switch inside the image on the screen?
Yes.
Okay, well, we also have this part right here, and this is called a coil. It could also be called a solenoid, where when it's given power, it becomes a magnet. It's the same thing in a water valve. Most motors use magnetic force, so forth. So when we add a relay, we add a second part called a coil. A coil, when I put power to this, a magnet will either push the switch closed or pull the switch open. So on this screen, I go back to my share screen. You know, I wonder if I could do that. Give me 1 second here. I think if I can. I open up my camera app, and I open up one of my other cameras here. Okay. Can you guys see that?
I see you.
Okay, well, what if I hold the relay to this
I have
camera?
a big picture of you and a small picture of a relay.
Yeah, no, but I'm not trying to do the relay. I'm trying to actually show you the relay I have here.
Oh,
With,
okay.
but this way I can use full screen.
Okay, yeah, that's better.
Okay, so I just turned on the camera app on my computer so I could show it. Okay, let me move my keyboard out of the way. So here's the push to start relay. All right. It has a magnetic coil inside, which is this black round piece here. And on the bottom, it has a switch contact. Let me see if I can get a good picture of it. Now that's over my finger right here. And watch when I press this button down here. Now it's backwards from my screen, so when I go left, it goes right. But if you look here, this here, when I press it, you see how the switch contact where my thumb is making contact?
Yes.
It's up here at the top. But the black coil, watch what goes on here at the black coil when I'm pressing. What do you see happening at that coil?
I can't really tell.
Okay, let me get closer. I know the focus is not perfect, but I'm sorry. But it's just basically a piece hitting that coil, right?
Yeah, it's
So,
going up and down. Yeah.
yeah, so what happens is when I press this down, if I let it go, there's a spring in there that's pushing the switch back open. And on this dryer push to start switch, we want it to stay closed so the dryer doesn't continue to run. So what happens is that magnet, when it gets power, pulls this piece and holds it there. So when I let go, it would stay in that position. So we have 3 pins on here, okay? And 2 of the pins are the relay coil. And you see it says, it doesn't have anything marked right there, but it says CT1. And I don't know what it says there. I can't really see it in the camera. I think there's a C printed right there. So these 2 are that black relay coil. I keep pointing to the wrong thing because I'm on the wrong side of the. So this black coil is getting power from these 2 pins right here. And when I close, power comes in one pin and goes out the other. That one's going to the motor, making the motor work. How do we test this? Well, this 2 are going to be our coil, and these 2 are going to be our switch. So I'm looking for resistance when I check the coil. So let me do this. I know it's not a perfect angle, but if I put it too high, you won't be able to see what I'm doing. So if I check the 2 pins at the bottom, I'm going to be getting a resistance reading. So when you use an analog meter, you always want to adjust your meter so you close it like this. And I don't know, I'm sorry. Can't do it upside down. There we go. So when you use an analog meter, this meter has multiple batteries in it. So you have to touch the 2 leads together like so. And then adjust this to make up for the different batteries in there till it's on 0. And I adjust it just to about 0. So now I want to check the coil. So when I go to here, and I'm going to move this back some, I'm going to check this pin and this pin, and I should get a resistance value. The needle barely moved. When that happens, I have to change the scale. Right now you can see barely, I'm on R times 1. I'm going to go R times 10, which means I'm going to use whatever reading I get and multiply it by 10. Check my meter scale real quick because now I went to a different scale. And we'll check here. And now I got a little bit more reading. Still not high enough for me to read, but you guys can see the reading there. That's probably about between 100 and 200 ohms times 10. That's about 2,000 ohms of resistance. So did I do a continuity test? If I move the meter back down, notice the continuity tester works here, but it doesn't work there because the resistance is too high. So the needle movement is the resistance. The continuity is just that, like a switch is open or closed. So I'm going to go ahead and check the switch part of it. I'm going to check this pin and this pin. And while I press the button, I just want to hear it if it gives me an audible tone. And to do this, and press at the same time. I'm gonna have to use the table to press on it. 1 second. Trying to do it with 2 hands and be in front of the camera is hard. Okay, so I touch the 2 pins. So the switch part of it is good. So checking from this pin here to this pin here, I'm checking the actual switch inside of the timer, and not in the timer, but in a push start switch. So the newer ones now, you can't even see. They don't make them clear where you can see the switch inside. So that's a push to start relay. Now, let me ask you a question. On the push to start relay, if I energize this magnetic coil and it stays down, right? What's going to turn it off? Because it's sending power to the dryer motor, but I need this relay to shut off so it'll open back up and turn the motor off. What is going to do that?
Would it be the timer?
The timer. That's what the timer's for. And remember, I said a little bit earlier, I said that we have to have many controls in front of different components in order to control them many different ways. Timer controls something, how much time it runs. Thermostat controls something by temperature. And then you have a high limit thermostat, because if the one for temperature doesn't work, the high limit is going to shut it off. So let's take a look at this timer. So the bottom of this timer here, we got all these different pin contacts for our wires. And let's take a look inside the timer. I have my tools here. I'm gonna take this off. Excuse the mess, guys. I'm taking off the screws in the front cover here. And carefully, you can open these timers up, and carefully, we pulled off the top. Now we have all these different switches inside that are either open or closed. And we call this part of the timer the cam. And if you could see that they have different portions that are cut and raised on the timer. I was looking at the wrong screen, sorry. So these are all the cams. And when I rotate it, let me see if I can show you. When I rotate it, it's a little hard to rotate while it's open. I got pliers here. So when I rotate it, watch what happens to the switches. You know what? Some switches on this side are not going to close, and I'll explain to you in a second, because this timer's been open before. But watch these switches on I guess it's your left-hand side of your screen. I'm gonna show them like this. Watch this white piece of plastic and what those switches do when I rotate the cam. I'm trying. You see how that switch is activated there? Inside the timer? That right there is the cam, and as the timer rotates, certain switches are open and closed in there. So I'm going to pull this cam out, and this little gear right here is this timer motor right here. It's got a gear, and that's what's turning the timer right there. You could have a good timer and good switches inside of it, like here, but the gear on the timer could be stripped out, someone rotating the timer too fast or something. So you may have power to your timer, and when you turn the dial, the switches themselves open and close, but the customer says it never shuts off. You could have stripped gears inside this timer. Now, the reason why I said that these switches here are not going to open and close is if you look on this side here, this white piece of plastic, this rides on the cam here, and this is what's cycling your switches. Someone opened up this timer, and on these 2 plastic pins here are supposed to be something very similar to this white plastic that cycles the switch over here. So when you're looking at a diagram of a dryer, let's just take a look. Let me bring up a Whirlpool dryer diagram. Okay, let me bring this one into screen here. Thank you very much, Tech Circuit, for your diagram. So if we're looking at this diagram, if you look, timer switches are identified by the big, bold contacts. We got a timer switch here, black to blue, black to violet, black to red, TMOR, TMWB. All of those are what's inside of this timer. I'm going to put this diagram just a little bit off to the side here if I can. I don't want to lose my picture here. This computer wants to force it. There we go. So if we look at this timer here, on the bottom of the timer here, we're going to have, I don't think it's that clear, is it? You can't really see it too well. Let me see something here. They only have letters. This isn't a Whirlpool timer. I apologize. But if I was looking at a timer, black would come in one of these pins and go out to blue and violet. If you guys look at this diagram, let me put them side by side for a second.
So you would just basically follow the colors for the wires.
Yes,
From
but
the
in this case, this one don't have those colors, but watch this. If you look, you got black, blue, and violet. So how many wire terminals are there based on the colors?
I can't see it really.
Okay,
Black,
I'll make it bigger. How about this? You got black, blue, and violet. So how many?
I got 3.
We got 3 connections, right?
Yeah.
So now let's look at this timer here. Okay, so if we look at this switch that's here on this side, do you see the 3?
I have 3, yeah.
Okay, so if I push this, now watch this. If I push this, it makes contact here, or it makes contact there. What's missing is if I pushed on this outside one. I'm trying to do it upside down, guys. You got to apologize to me. I'm going backwards and upside down. So if I push in, I can push this contact so all 3 of them are touching. Let me see how I get this on the camera in so I can see what I'm doing. So if I push it here, all 3 of them are touching. If not, if I push just a little bit, let me take I'm caught in the plastic there. I could just have it touch the center one, or I can have it touch all 3. If not, I go back. So which one of these 3 is the common one? Is it the one on the bottom, the one in the middle, or the one on the top?
Would it be the one in the middle?
It's actually the one on the bottom.
Because it goes to all. It touches all.
Touches the middle.
Touches all of them. Yeah.
It touches all 3.
Okay.
Now let's go look at that diagram for a second. Look at the black. It's on the bottom. And if I push it just a little bit, it's only going to touch the blue. But if I push it even harder, what happens?
It goes up.
It closes all 3. So you see how those 3 pins inside the timer, and I'll just put it, let me make it smaller, just the camera picture. Those 3 pins inside the timer there, these 3 right here, are these 3 right here.
Yep.
Now, you're not going to open up a timer to say, well, I see the diagram, but I can't see the switches. They're inside this box. I can't see what's going on inside there. That's when we want to go to the back of the timer. And in this case, it has letters A, B, and C, and I just didn't have that diagram. I had this part at my school, and I just took it to bring it in and show you what's going on inside. But they would have A, B, and C on the wiring diagram if you had this timer. So BK would have been A, B would be B, and then V would be C. And that's how you would know which pins to test. If I wanted to check the bottom switch here, I would just go black to blue. And if it didn't have the letters there, you could actually look at the color wires. You'd have a black wire on one and a blue wire on another, and I'd have a violet wire on the other. And I say, well, that's the black wire there, and the blue wire is there. So I guess that must be that switch right there, because this switch down here has what 2 color wires?
So, Richard, according to looking at this, is that black always got power on it?
Yes, that black, if we bring it down, that's line 1 coming
line
in
1.
here. Do you see that?
Yeah, Mr. Rich, that's why I was saying I wasn't thinking that the timer would be even open. I would just look at the wire colors and it would tell me
Yes.
what it's actually doing, because I'm not going to open the timer. You know,
Exactly, but and that's what I want you guys to do but I want you to understand how these things work. So get yourself some junk. Even if you pay $25 for a machine, strip all the parts of it, take the timer apart, look at the switches inside, rotate the cam, see if you can put the timer back together again and make it work. You know, I've seen points in here burnt, and I've taken a little Emery sandpaper or a little nail file, you know, there's the little emery board nail file that women use for their fingernails. I put that in between the points and I sand the points clean, and I can make that switch work again. So that's the inside of a timer switch. How about that switch? Do you know that that switch and this switch have something in common? And this switch. Does anybody know what all 3 of those have in common?
Contacts.
They have contacts, correct? That's one thing. But these 2 are different. What's the difference between these 2?
it's a single throw.
Well, they're both single pole, single throw. They both only have a place for 2 wires. I'm going to put another one of them here. Something else here. What is this? And what is this?
I think the infinite switch you can move physically. Physically move it.
Well, I mean, we physically move this, don't we, when I press the button down? Okay, so what I'm getting at is this is a mechanical switch. When I push it down, I close the contact. When I let go, I open the contact. Some mechanical switches, like a microwave door switch, is closed when the door closes and keeps it that way. And when you open a door, it does that and the microwave stops. So these are thermostats. Or actually, this is an overload for a compressor. But guess what? It's a thermostat. It's a switch just like these switches inside. But when certain heat is applied, a lot of them, I had one of these in my hand to bring to you. I was going to show you inside. Has a little metal disc called a bimetal. It's just like a little flat piece of stainless steel, thinner than a dime. And when it gets heated, that piece of metal is actually 2 different pieces of metal. We call it a bimetal. And when it's heated, it's like a contact lens. It's like this, and then it pops up when it gets hot. When it cools down, it goes back down. And on top is a little pin that pushes the switch up and down, like I did on a door switch or I did on this switch. So imagine that bimetal on the bottom of this here, and then when it's heated, the bimetal pushes it up. When it cools down, the bimetal goes away. So these are actual thermostats or bimetals, and I have some picture to show you real quick, and then I'll go back to this infinite switch here. Here we go. Just got to figure out which screen. Look at these 2 little thermostats. These are the ones I had on the table. And they have information here. It says L150C. What does that mean?
It's the temperature at which it either opens
Or close
Okay.
or closes.
And what temperature is that?
It's 150 degrees.
150 degrees
Yeah,
Celsius.
Celsius.
That's important that you pay attention, because some parts are rated in Celsius and some parts are rated in Fahrenheit. What's the L mean?
Is that low?
Actually, L is the limit. In other
Or is
words,
the limit? Oh, okay.
below 150 and below, we all good. At 150, that bimetal opens up and pushes the switch contact open. So in between these 2 is a switch, just like that switch I was pressing with my finger. But on the bottom here is a disc, and when the disc gets hot, it pushes up on the switch. What people think is you need to have electricity here. I do not have to have electricity to make this switch open and close. I just have to apply heat to the bottom of it and cause the disc that's in here to pop up and push up on a pin that opens or closes a switch. Now, not all of them are closed. Some of them are open and then they close later. take a look at all of these switches. I'm going to give you a little bit of information. And then I got a little question for y'all. So I want you to take a minute and look at the information, and then I'll tell you what I want. Okay, so operating temps and high limit temps. Operating temps are 120 to 160, high limit temps 225 to 325. I'm talking about the temperatures inside of your dryer. Dryers operate to maintain the temperature coming out of the dryer to be anywhere from 120 to 160, from low heat to high heat. Low heat is about 120, 130 degrees. High heat coming out of a dryer is approximately 160 degrees. Now, high limit thermostats are 225 to 325 degrees. These are all temperatures based on Fahrenheit. Now, I'm going to go ahead and label A, B, C, D, and E. I want you all to take a minute. I know this little one here don't have a marking on it, but I want you to look at them all, and then I'm going to ask you guys, A, is it an operating or high limit? And then what temperature does it actually run on? So looking at A, what is it? Is it an operating temp or high limit temp?
Operating.
Actually, it's high limit because I put 225, but this one actually says what? Its limit is what?
Its limit is 200.
It's 200. Why is there a minus 70?
That you subtract the 70 from the 200.
I'm sorry, Joyce,
Is
you were
that,
about that.
is that when you subtract 70 from 200 to get the low?
Not necessarily the
Low
low,
range?
not necessarily the low. So the limit is the point in which most thermostats will open or in some cases close.
Yeah.
But the limit is that once it gets to 200 degrees, the switch between these two contacts will open up.
Okay.
Now, when it opens up, what does it do? It stops power from going to the heater.
The heat, yeah.
Yeah, so then it's got to drop to 130 degrees Fahrenheit
Mhm.
before the thermostat contacts will close.
Start the heat back.
So let me ask you a question. What is the average temperature that this unit runs at?
120 to 160, you say, right?
No.
270 divided by 2, right?
Now 270, the high temperature is 200, the low temperature is 130. In other words, 200 minus 70 degrees. So it shuts off at 200, but it turns back on at 130.
130.
130, okay.
So you basically have to go halfway between 200 and 130.
Yeah.
You can add them together to be 330,
Mm.
and then you divide it by 2, and that's 165.
165, yeah.
That's what the average temperature will be. But remember, it will go as high as 200. It's just not going to stay at 200. That is a safety. You wouldn't want an operating thermostat in a dryer to have that big of a temperature swing. You want thermostats. Just imagine baking your cake and the instructions say bake a cake for 20 minutes at 350 degrees. Well, your oven goes to 500 and shuts off and comes back on at 200. No, you're going to burn the cake. You want to shut off just a little bit above 350 and then come back on a little bit below 350. You want the on and off temps to be as close together as possible, because the less the swing, the more accurate the temperature is going to be inside the box. Have you ever been inside your house with the AC on and you had the AC on automatic so that, once it reaches temperature, even the fan stops, and you're sitting there and you're like, yeah, it's getting warm in here. And then a few minutes later, the AC kicks back on. And that's that temperature swing. So let's look at thermostat B. Thermostat B is what? Operating or high limit?
Is it high limit?
No. What's the temperature
I
right
see
here?
155, and it's another number. I can't see the other.
95? Look like
Actually, that's
95.
an F. That's an F. It got cut off.
Oh, okay.
I couldn't find another one. So that's 155 F.
Okay.
So which one is it?
It's high limit.
It's operating. High
So that's in
limit.
between 120 and 165.
Yes, 155 is just under 160.
It's under 160. Yeah.
So it would be the high heat out of low, medium, and high, but you know it would not be like high limit. High limit would be you got the operating thermostat like this. This is what's in the dryer to control the temperature of your clothes. But what if for some reason this fails to turn off the heating element? Well, we got to have a backup. So that's where we go with our high limit thermostat, like this yellow one here. So we'll put power in here, and then we'll connect this one to here, and then this one will actually go to your heating element, so that this one here is going to turn off at 150. This one just sits there and says, okay, go ahead, do what you want to do. But if this one fails to shut the heater off, well, we have this one here, and this one is always mounted on the heater, where this one is always mounted on what we call the exhaust housing, where the air is coming out of your dryer. So this one's measuring the temperature of the air leaving the dryer. This one's measuring the temperature of the air at the heating element.
Mhm.
I'll show you something. I got a question I'm going to come back to later, but we got so many things I got here, and I've already read across the hour. I'm going to go a little bit over today, but I want to get over these parts. So look at C. C looks like those little ones I have pictures of. What do you think C is?
High limit.
It is a high limit, but it will also have a name as thermal cutoff. Sorry, I should have typed it, but thermal cutoff. And the thing about these is that those are usually not resettable. Like these thermostats here have that little disc I told you, like a contact lens that cycles the switches on and off. This one, usually when it fails, it's a one and done thing. It does not reset and has to be replaced. But that comes with this one. What is this one? High limit or operating?
Let's see. Which one you looking at?
D.
D.
And that's in Celsius.
That's operating.
It's not operating. That's a trick. That's
Oh, no.
125
High
minus
limit,
31.
because it's Celsius.
It's Celsius,
Celsius,
but if
yeah.
you go 125 degrees Celsius, what do we get?
257 degrees.
257.
Mhm.
Okay, so the point I'm bringing about this is, this information is printed on all these little devices, and you guys probably don't even read that, or if you did read it, you say, well, I don't know what to do with that. I don't know what the numbers are. And listen, I've had people tell me, hey, I don't have a Whirlpool thermostat, but I have this GE thermostat. Can I use this one instead? Well, this one is what temperature? 155. What's the temperature of this one? E.
Can't see that.
Okay, hold on. I'll make that part
see it.
bigger, and I'll turn it over because it's upside down. Hold on 1 second. Click on it. I will rotate it, and then I'll make it bigger.
The 155 Fahrenheit.
That's 155, but this one here, B, is also 155, right?
Yes.
Could I use one over the other? Yeah.
But it has 4 plugs. Yeah.
Yeah, it has a little bias heater on it, and this one has a bias heater. I don't want to get in that today, but that's a whole nother subject. But the thermostat contact itself, in other words, hey, I have one on my truck, but I don't have a Whirlpool one. Can I use this? Well, if I know that they're both 155-degree thermostat, you can use either one. It doesn't matter. So that's an operating thermostat. That's an operating. These were high limits on the outside. Any questions on those?
No. Operating.
Now, another thing is most of them have the part number. This yellow one at 314924, you could look that up on Google right now. It's the part number. And this 1371167 is also a part number. This TSD 301C, that's like a generic part number for the same part we have here, which is, I think that one is, this one down here is 387134. So those are the part numbers too. And a lot of the parts have the part numbers on them.
So you said that, can you go back real quick?
Yes.
So you said that the operating switch goes on the heater.
I'll get you a picture. I'll show you real quick. Yes, I can find the image. It'll take me a second to find it, but there's a guy out here that has a picture of the back of the dryer all open. Okay, I'm gonna copy this image. I'm gonna go to a blank page here real quick and paste this image in. So this is the back of a Whirlpool dryer. This is your heating element right here. Okay, this is where the dryer vents outside. This is our exhaust housing. Inside of here, we have a fan blade that circulates the air. And I know the picture's not clear, but that is the operating thermostat right there. Okay. The high limit thermostat is right here on the heater. Now remember in this drawing here, or not drawing, but I showed you a high limit and a thermal cutoff.
Mm-hmm.
Well, they didn't tell you the temperature, but that thermal cutoff is probably running about 325 degrees, even hotter than the high limit. Now watch this. Air comes in here and goes over the heating element. On the other side of this housing goes into the drum where your clothes are, and you can see the round circle, semicircle here. That's the drum, and the air comes over here, and this is the filter housing where the customer cleans the filter. The air comes back from the drum into this housing. There's a fan blade here, and then it blows the air out. So as the air comes in, this is 250. This is 325. And again, some manufacturers might be slightly different, but this is average. And this is 155. Okay? The black one down here. So as air comes in, the air is being heated by the element and goes into the drum and comes back through the filter housing and blows out here. As the air here reaches 155, that thermostat opens and stops the power from the heater. Okay, hold on 1 second. I'm going to bring back a another diagram here. And this is my good old friend here, Plantology. 1 second. So if you look at this diagram here, here's your operating thermostat. What does it say here on the diagram? 150, 155.
155.
Okay, and it's in series with what? The heater.
Mm-hmm.
So this one here is what's supposed to turn that heater on and off to control the temperature coming out of your dryer. Now, what if for some reason the contacts got stuck together? Maybe the customer had a power surge and welded the contact together, and that thermostat here doesn't shut off. Well, we have no way to turn off the heater then. So then we have the high limit thermostat. So the high limit thermostat will say, hey, it got so hot, stop the heater. Now, one thing we didn't talk about is there's another piece right here behind that thermostat called the thermal fuse. Does anybody know the temperature of that? That's 196. Just above 155, but not so close that it'll go bad by mistake. But 155 degrees here will turn the element off. But if this fails, now the temperature goes higher, less than our high limit, 196, that thermal fuse will blow. Let's look at that diagram again. Our thermal fuse is right here. You see it says 196? If that thermal fuse blows, what does it do? It controls what?
The motor.
The drive
Everything.
motor.
Yeah.
Okay, so that comes to something I lecture a lot. You go to someone's house and their dryer's not working. Hey, Joyce, I need you to check out my dryer. It's not running. Oh, well, sir, the reason it's not running is your thermal fuse is open. I got a new one in the truck. I can put a new thermal fuse and the motor's going to run again. But did you fix the problem?
No.
Well, you got to find out
temporary.
why it's actually making it blow.
Exactly, because it's a fuse. If you put a microwave that's got a blown fuse, yeah, sometimes you put a new fuse in there and it's working, but sometimes you put a fuse in there and it blows that fuse too. Changing the fuse doesn't always fix the problem. You have to find out what blew the fuse in the first place. So the operating thermostat, if it doesn't operate like it's supposed to, the thermal fuse will go bad and shut the whole dryer off. So, hey, we're getting too hot. We're going to shut this thing down and have someone come out and look at it. Okay, but I was telling one of my students, okay, well, my operating thermostat's here, my thermal fuse is here. Well, why do we put this high limit here? We could still put it here if I want, right? Why is it here on the element and not way over here on the exhaust?
Well, that's what the heat's actually getting made
That's
over
true,
the element.
but that doesn't explain why they put them in two different locations.
But the heat has to go inside and get to the drum that's actually turning to circulate to come back through the air side. So does it cool
true,
down?
but here we're allowing fresh, cool air, which is 70 to 80 degrees in someone's house, over that element. So this housing, yes, it'll get hot. I wouldn't touch it while it's running, but it's not going to be 250 degrees hot. So the reason why this one is over here and not next to this one is the filter's on the top here. If the customer takes the filter out to clean it, is it possible they could drop a sock down in there or something?
Yeah.
What if the filter, which runs all the way down, you guys seen those long Whirlpool filters? They go down in there, you grab it from the top and pull it out. What if the customer never cleaned the filter?
Yeah, it can start a fire.
It'll start a fire. I had a customer, I was working for BrandSmart. If you guys know South Florida, BrandSmart is maybe got one in Georgia too. BrandSmart, I was a tech for them, and the customer's like, my dryer's not drying my clothes. So first thing I want to do is I want to pull this filter out and check airflow coming here. And I'm not going to get into what I was checking, but I wanted to pull it out. I couldn't get the filter out. It was stuck in there. I pulled so hard the handle came off the end of the filter. So now I got pliers and I'm pulling the thing out. And the lint was so thick, it wouldn't allow me to slide the filter out. I said, ma'am, you got to clean this after every load. Oh, I do. You could look at the filter and all that lint. And, like rings around a tree tell you how old a tree is. Well, the lint on the lint filter was different colors. You could almost tell how many different loads she did.
Yeah, layers.
Before it got blocked up. but the point is, if that airflow is blocked here on the drum, we have seals. If the seal comes off the drum, we pull air in around here and not through the element. We don't get proper airflow of the element. If the customer pushes the machine against the wall and that flexible hose that comes back here is crushed, well, even if the fan's running, it's still not circulating enough air coming out. So this whole area is going to overheat because we have no air circulation. So now we have another thermostat at 250 that says, hey, if these two here cannot see the temperature because the airflow is blocked, then this thermostat here is going to take over to prevent a fire. Now, if it's still got too hot, well, this one's at 325. That is a thermal cutoff. And if we go back to our pictures here, our thermal cutoff was here at 325. This piece here is not resettable. So this one will reset and operate at that 250 or 255 or whatever. But this one here eventually will go bad. And the reason why they're in a picture like this is because most machines, if you order a high limit thermostat, it comes with a thermal cutoff. They want you to replace both. Because most likely, and on the Whirlpool Duets and the Samsung dryers, if you've worked on any of those running, not heating, this thermal cutoff is what you would see on the side of that heating element. That fails a lot. And it could be because of airflow. But if you get a new one of these, it comes as a kit, the high limit and the thermal cutoff. So if we look at the diagram, I can bring the diagram up here. Right here. If we look at the diagram, here's the thermal cutoff and the high limit thermostat. All three of them are in series with the heater.
Mm-hmm.
The heater don't work. Any one of those could be at fault. But if this thermal cutoff is bad, you need to investigate further. You need to check airflow. And again, knowing that this one fails because of airflow, and this one failed because of something else, is how you're going to troubleshoot the machine. And that's up to you to understand, whether you guys are here in a class like this, or you're reading a book, or you tear your own machines apart. And if you guys got questions, I have no problems with you emailing me and saying, hey, you know, I was testing this part at home and I don't know what this is. Send me a picture. I'll respond to you. I'll put in the chat here my email address. Where is the chat here? I think right here, right? No? It's been so long since I used Google Meet, but I don't have a Zoom account. I always use Brandon's, and I didn't have time for him to create it. Do you guys know where the chat is on here?
I have no idea.
Turn on captions, turn on camera, you are presenting. Oh, I see right here, chat with everyone. Okay, I'm putting it in the chat if you guys, and don't
Okay, I got it.
don't bar me 5 times a day. Hey, I got this dryer, runs and don't heat, and what do I check? And now my second call, my refrigerator don't work. That's what we have Voxer for. And I do go on there, not frequently, but I do go on there and help guys out. Some people will tell you that I've helped them out, whether I give them documents or I give them advice or something. But yeah, if you're checking out your machines at home and you want to know a little bit more about specific parts, email me and I will respond. Not right away, but I will respond. You won't have to wait a week for a response. I will give a response on that. So going back to our parts now, again, knowing each one of these parts, where they are in the machine, what they are, and you can see the temperatures that they have here that they cycle and operate. All that is there, as well as put on the part itself. Now let me go to my thing here. So I have this. What is this?
It's like a thermostat.
It is, but does anybody know what type of thermostat it is?
Defrost thermostat.
A defrost thermostat.
Mhm.
It has another name. Sometimes people call it something else. Do you know what they call it?
Bimetal.
A bimetal. You know what? Bimetal is what's in the bottom of all these thermostats.
Mhm.
It's a bimetal that opens and closes it. This is the same thing. It just got a little disc in there. It's a thermostat. You can call it a bimetal if you want. The reason why they call it a bimetal is so that you know, when you're ordering a part for a refrigerator and you need the thermostat for the refrigerator, or you need the defrost thermostat, let's just call it defrost bimetal so we don't confuse it with the regular thermostat. So that's why they do it. Like a thermal cutoff and a thermal fuse on a dryer. They're both fuses that blow on temperature, but we give them different names so we don't make a mistake ordering them. So what's the temperature of this one?
47 to 22.
Okay, so 47 means that what happens at 47?
That's the limit.
That's the limit.
That's a limit. And so what physically happens?
And it closes.
It opens.
Opens. Yeah.
Oh, it
It
opens.
opens at 47 degrees,
Okay.
and it will close again at what temperature?
Minus 22. Okay, so you subtract the 22 from the 47. Is
25.
that it?
That'd be 25 degrees. So at 25 degrees, this thermostat will close. So can you put it in a glass of ice water and get it to close?
Should be
Yeah.
able to.
No.
Oh.
No.
Ice is 32 degrees.
32 degrees. Okay.
So if you think, oh, I just took this bind and I'll throw it in ice water and I can tell you if it's good or bad. No, you can't. Because and there may be some that you can, but you have to look at this and know what this is, so you can test it.
Okay.
Okay.
Yeah.
Now, I have the relays and stuff I wanted to go over more. I'm gonna hold them off to next week, but I do want to go over one more part because it's in regards of this. Give me a second. I'm looking for an infinite switch on a stove. I'll bring the screen up so you guys can see what I'm doing. And an infinite switch for the stove. I got one here that I'm gonna open up and show you guys inside, but I wanted a picture because the pictures I can usually get a little bit more clear. Obviously, I'm not gonna find the switch I'm looking for. This one here, but I want a picture of the inside. Okay, perfect. Stop. I didn't want to rotate. So look here, this is your infinite switch. Infinite switch has multiple contacts. Let me see something. Okay, if I can rotate left or right, should be able to rotate it the other way too, but I can't. Okay, but the infinite switch has markings on it. Let me copy this image and then bring it into where I can draw on it. Okay, one more second, guys. I have to go into my pictures and go into my screenshots, and it's somewhere in my screenshot here. There it is right here. So I'm going to bring that into my other drawing program here where I can write on it. Here we go. Sorry, guys. So here we got an infinite switch. Okay, it's a little hard to read, so I'm going to write on it. This is L1, L2. You can see it here vaguely. That's H2. This one is H1, and this is P. So inside of here, and I'm going to open it up and show you, this is a common position here. The P is the indicator light, and you know, this goes back to gas stoves where they had a pilot light. They never changed the P to indicator light to make it an I or whatever. They just kept it as a P. And the H is one side of your heating element. So you got a single pole with two contacts over here, almost like that dryer where I showed you black to blue and violet, where one hits two pins. And this L2 to H2 comes into here and comes to here. And the switch is right underneath here. And I'm going to show it to you. I'm going to break open the switch in a second, show it to you. But does anybody know what this crazy thing is right here?
Thermal limiter.
Close.
Oh, I'm out.
It's a bimetal.
Yeah, I was going to say that, but I didn't know. It looked like metal.
Well, it's a metal switch, but they have a little heater on there. And so the way it works, real simple. You got line one that comes in. It goes here to L1 on your switch, and that switch has a contact to H1. H1 means what? Why has one got an L, one got an H?
One is your power in, one is going to your heater.
Yes, this is line one coming in, L meaning line. H is telling you the heating element. So that it's H1, so it's bringing line one to the heating element. So here's our heating element. And then on the other side, we got what?
H2 and
H2.
L2.
And then L2. Okay, so that's the two switches in here. But the H2 to L2 is a bimetal. So when you first turn this switch on, both contacts close and the element works. If I put the switch on high, these two contacts stay closed the whole time, and the element gets red hot and never turns off until you turn off the switch. But if I go anything other than high, what it does is it cycles like a bimetal, just like a dryer thermostat. And when electricity flows through it, the amperage across that bimetal will cause it to cycle open. So it turns the element on and off and on and off. If you have it on high and then you go down just one setting to 9, like the next lowest, it'll stay on 90% of the time. 10% of the time it's off. So it comes on and stays on for a long time, then shuts off, comes right back on and stays on for a long time, shuts off and comes back on. If I go to 5 setting on the infinite switch, it's on part of the time and off part of the time, but its on and off times are about the same. If I went to 2 or 1, it's the opposite. It comes on, shuts right back off. Comes on, shuts right back off. No matter what, you're getting 240 to the element. But you're cycling it, and that's a bimetal, which is basically the same thing as a defrost thermostat, an operating thermostat in the dryer. All these components are the same. If you know how one works and how to test one, then, you know, that's going to make your life easy. So let's go back to the camera, and I got an infinite switch here. And I'll show you 2 tricks with an infinite switch. Let me first move my keyboard. I'm going to go ahead and remove the cuffs.
Tricks for the infinite switch.
Okay. And what are these, guys? You saw something like that earlier.
That's like a cam, right? Or
It's a cam.
Cameras we had in the timer.
It's just like the cam. So the reason why I'm pointing that out is because there's only so many ways these guys can do these things. A timer and an infinite switch and all this stuff, they have so many similarities. So break everything down to its most simplest form so that you can build up your understanding and then get more technical to computer boards and everything else, which I'm going to probably have to put that to the next class where I'm going to talk about relays and I have this contactor and I have a fan relay and stuff like that. These parts here I want to show you, but we just don't have time today. So anyways, when I rotate this cam, I'm pushing. I don't know if you could see it just at the very top, but when I rotate the cam, could you see that switch going up and down?
Yeah.
Up here?
Yes.
It's going up and down. So that's the switch contact. That's the bimetal inside. I'm going to go ahead and just pull that baby open. And so if we look here, that right there is the contact. And down here is also, but down here is also the contact. Let me get my meter lead so I can get my big finger in there. So right down here is one contact, and the other side, and I'll show it to you, let me see here, is the other side of that contact. You can see that they're pitted and burned, right?
Mm-hmm.
That's normal for switch contacts. Every time a switch turns on and off, it does pit and burn. And this piece here is the bimetal part of it inside. Let me see if I can get down in there. I'm going to push it up from underneath. This piece right here on the bottom, which is the switch on the bottom that I pointed at, that burnt part right down in there, that whole thing has a wire wrapped around it, and that will warp when it's heated.
Oh,
And
you
so
got it was off the screen, Mr. Rich.
it's
you
up
move it to your right a little bit.
Yeah, there you go.
There you
here.
go. Yep.
Okay, so
Yep,
you guys
that's
are looking. You're not looking at my screen share.
We are. You just was somewhere else. You had half the switch on.
Oh, I'm sorry. Yeah, I'm looking at what I see, and I got the whole screen here. I don't know how you guys see it. So, anyways, this is the switch that's pushed down by the cam, but the piece inside here is the bimetal part that actually cycles the element on and off. So if you had a customer complain that she puts it on high and it never goes off, this contact right here could be welded together. And what does that mean? Well, it means an electrical short might have happened and burned that contact together. Now, on the old coil type burners, not the glass top stoves, I don't know if any of you guys changed those little terminal blocks that the burner plugs into because they burn out. Well, sometimes those wires touch ground and they short this and they damage a switch. So if you got a customer with the old style burners, those round coil burners, and they tell you, yeah, the burner works, but it only works on high. I can't turn it down. It's just on or off. Well, okay. Before you change this switch, lift up the top and make sure that there's nothing there that shorted that damaged this switch in the first place, or otherwise you're going to change the switch and blow it out again. So this was L2 to H2. Okay. This one here is the L1 to H1. And if you can see down in here, we have, let me see if I can get it in the screen a little bit better. When I push this down here,
Move it to the right a little bit.
okay, right here.
Right there. Yeah.
Okay, so when I push this down a little bit, you can see the switch contact being made. And you can see two rivets just below where I was touching down there. Those, if we turn that over, that's your H1 and P. Look. That's your H1 and P that I pointed out. Those two rivets right there. And then this rivet here is your L1. So if we go back, L1's coming in here, goes up through here, goes to your burner H1. Your burner's out, comes back to the other side, comes in to here, and then goes to L2 on this piece right here. So that's the inside the switch. Now I told you I was going to show you two things. One, I've seen these welded and that's what's bad. But what if you had an infinite switch that looked just like this, right? But the shaft was different. This one here, the shaft on this one is D-step. It has like a flat spot on one side and then semi-round, like D-shaped, like the letter D. Okay. But the one you had in the customer stove wasn't as long or wasn't D-shaped. You're like, man, I got this switch. I could just put this switch out, get this job and get out of here. Well, you saw I opened it up, right? I open these up all the time. And then I just put them back together and a pair of pliers, squeeze it back on. So why can't I take this cam out of the old switch and put the cam in the customer's new switch that has the right shaft and make it work? So I have switched cams out of switches to get a completed job instead of having to order the switch and come out. Now, when you look at these switches, remember we looked at those thermostats, there's important information on the side of the switch here. Let me see if I can go closer to the camera and get it on the camera. I don't know why it's not showing too clear here. Let me see if I can get it on the computer here. If I go back to this infinite switch here and I rotate it, you guys can see the information clearer, right, on that?
Yes.
Okay, so what information here is valuable to me? If you see this shaft here is different than the other one. So I was like, man, if I could switch the shaft, I could make this switch work. What do I need to know about this switch that is important to me to say, okay, well, the switch looks physically the same, but if I change the shaft, will it work on this customer stove? Just like the thermostats, we were looking at all those numbers and information on them. What are you looking at when you're looking at this switch here? What is important?
Operating.
I'm gonna screenshot it and then bring it where I can put it in my software here and expand it a little bit and rotate it. Hold on one second. I'm here. Here it is. So let me just rotate it and make it even bigger for you guys to see. It's a lot easier when I'm standing lecturing in a class than using the computer, guys. I apologize. Okay, so what information here is important to me?
Watts and
Okay, wattage.
Get at 20 to 40 watts.
That's 2,040 watts.
Oh, okay. I can't really see. Okay.
But this is important also.
But the average
5.9.3 amps. What are they
yeah,
talking about? What are they talking about?
That's the range.
That is the range, but they're referring to that bimetal that I showed you.
Mm.
That bimetal cycles within a 7.5 to a 9.3 amp draw. And what's important about that is on a larger burner, you're going to draw more wattage and more amperage than on a smaller burner. So they have these switches that are rated for different amps, but they physically look the same. And you're like, well, heck, this one will fit. The shaft will work. I could connect these wires and I'm done. Yeah, it'll work. The problem is it may not control that element at the same temperature that the other three switches are doing on the stove because it's the wrong amperage. Now, the other thing is this WB24T 1027, that's a GE part number. But this 210-4103, I think, is a Maycore part number, which is like Maytag and Admiral. So I could use this switch on a GE stove. I could use this switch on a Maytag stove. I could use it on a Whirlpool stove. As long as my shaft is right and my amperage is similar, I could just get 2 or 3 switches. And when I opened up the one that I opened up for you guys today, I just took a pair of pliers and just like bit it here with my channel locks and here, and just bent this piece out, and the top cover comes right off. So next time you change an infant switch or you find an old stove, take this switch apart. Look inside of it. And then if you even can, what baffles people a lot more is now the new dual burners and the dual burner switch and how that works. Well, get an old one or buy a new one. Buy one for $10 off eBay or something, even if it was used, because you're not going to put it in someone's stove, and tear it apart. Look at it like I opened these parts up for you and showed you how they work. Doing this, guys, is going to make it easier for you to understand how these things operate, and then eventually make it easier for you to understand and troubleshoot.
Okay.
So I went a little bit over today, which is, okay. I don't mind doing it once in a while. I do have relays and overloads and stuff that, not overloads, but relays and contactors and those parts, which I'd want to go over, but I want to go a little bit more detail into these. I'm going to actually hook up some circuits and stuff like that and show you how can we make different things work, and how really does a relay work, and what's the point behind a relay, because we have relays on control boards. We have relays that are standalone relays like this. And I'm actually going to talk about a central air conditioning circuit and how these parts work in there, because it doesn't matter whether it's a dryer, washer, refrigerator, stove. If you can understand how these parts work, you're golden. So any questions about anything we covered for today before we sign off?
No, this was a good class. This was very enlightening.
Well, I'm going to do a lot more of these. I know that I have a lot of videos that are somewhat technical, but a lot of people, I realize in talking to everybody that a lot of people they're just not ready for that yet. They need to understand just the switch and understand why is it there and what it does. So I talked to Brandon. I am working, guys. Also, Brandon sent me a video. I am working on the online members videos to post more member videos in there. I am working on an online class, which would be structured by chapters that you can go through, that I will add videos with textual information. I will have questions that you have to answer questions as you're reading the material. And then after the videos and stuff, that you'll be able to actually take tests and stuff like that to check your knowledge and see how you guys are doing. I'm working on it. You guys just got to give me some time, because I own a business. I teach full-time at night. I do this with Brandon TMM, and it's very hard for me to manage the website, manage, everything else, but I'm working on it, guys. So if you be patient with me, I promise that there's a lot more good stuff to come.
Thank you, Mr. Rich.
Oh, appreciate it.
Anyways, y'all have a good, happy Father's Day. And for those of you that are not fathers, you still had a father, so you make sure you say Happy Father's Day to them if they're still around. My father passed a few years ago, but I'm still good. I got kids and happy life. So I'm going to enjoy my day tomorrow. And just so happens that I have Monday off of work too. So I'm going to make the best of it. So y'all have a good week.
I got a question for you, Mr. Rich.
Yes, sir.
Hey, I purchased one of those dollar charges, right? I won it in the auction, and I didn't realize that a certain dollar charge goes to a certain type of freon.
Yes and no. Remember, just like refrigerant gauges, you can buy gauges that do 134A. You can buy gauges that do 410. Pressure is pressure.
Okay.
If it's 70 psi, it's 70 psi. So once you have that refrigerant inside the dollar charge, still dial it to the pressure. I don't care if you got an R22 and you're trying to do 134A. Still dial the pressure at the top, like I do in the video, to the pressure on your gauge on the dollar charge. And then remember, an ounce is an ounce of R22 and an ounce is an ounce of 134A. So as you're charging the system, just count down how many ounces. If it's 3.5, count down 3.5 ounces on your dollar charge, and it's still going to be 3.5 ounces of whatever gas you're using.
Well, I wanted to bring it out to the school so you can check it out for me.
Sure, just come to my school, my public school at night. I'm there. I'm there Monday through Friday from 5:30 to 11.
Okay, I'll just email you.
You're gonna what?
I said I'll email you when I can come.
Oh, that's no problem. You have my number, right? You can just text me.
Okay.
Just text me. Just say, hey, can I come by? I mean, if you're in the area and you want to sit in one of my lectures in my class, I'm fine with that too.
Thank you.
I usually lecture on Tuesdays and maybe Wednesday nights, but Tuesdays around 6 to about 7:30. That's usually like the videos that are posted on YouTube are my lectures in the school. And yeah, I record them for my students, and that's how Brandon and I partnered up, and then we just created TMM and said, let's just share this with the world. So everyone, anything else before we go?
That's it. Happy Father's Day, everybody. Happy Father's Day to the mothers that's taking care of the kids without the father.
Yes, that too. That's appreciated. Okay,
All right.
everybody. Take care. Bye-bye.
All right. Thanks, Mr. Reed.
You're welcome. Take care.